So it's been a month since I last spoke about the design of my clock, and since then I've progressed things a bit, sometimes forwards and sometimes backwards, and this is where I've got to so far. So before going on with the video, I just wanted to talk to you, the viewers, a little bit about this channel, which I'm hoping is really here for horological discussion. I don't have a formal horological background. My background is more engineering, so you'll probably find a lot of what I do maybe quite strange in a horological sense. So please let me know in the comments if you've got any suggestions. So I have one immediate question for you, which is what sort of accuracy do you think we should be aiming for with this clock? So as I've mentioned in previous videos, we are planning to use Harrison's compensation methods, but I have broken one of his main rules, which is to use at least a second's beating pendulum. So my pendulum is half that length. So I may have already destroyed the possibility of this clock being particularly accurate. So I'm currently thinking that if I can aim for plus or minus 1 second in a week, maybe that would be good enough. Maybe I should be a bit more ambitious, but I would love to know what you think. So now we'll return to the main video. I think I'm more or less happy with the layout, which I'll talk about in a second. But one of the big issues was that I wanted to have this as an 8-day weight-driven clock. So I thought I'd better do some calculations on the likely power requirements. And I've based this on my last clock, which has a grasshopper and a remontoir. And I thought it would also be interesting to compare the power requirements with my Woodward clock, which is very traditional, heavy pendulum, suspension spring, no remontoir, and weight driven with a Huygens pulley system. So I thought it would be interesting to work out the energy requirements of clock B as well. And I took this photograph of clock B at the NAWCC in June. So I'm going to use this and scale to find out roughly what the mass of the driving weight is. And I'll do this by using the known length of the pendulum, which is 1 meter. So starting with my clock, we have a 500 gram weight and an 8 centimeter lever, and the great wheel turns twice in 24 hours. So this gives an equivalent weight drop over 8 days of 4 kilograms falling 1 meter. And with clock B, I've done the scaling, and very roughly I've worked out that the weight is going to be about 0.8 kilograms. And the lever is 24 centimeters. And the great wheel rotates, in this case, once in 24 hours. And this works out at a straight drop of 9.6 kilogram meters. And just for a bit of fun comparison, the Woodward clock works out at a miraculous 0.9 kilogram meters in 8 days. So from this, it's obvious that grasshopper remontoir clocks are really not energy efficient, but that isn't their point. But this is going to have a serious effect on my clock because the drop is only, I think I can get about 350 millimeters. And doing the sums, that would represent, if I was going to run it off 2 weights, one either side of the pendulum, that would be 6 kilograms per weight. And I think that's just way too massive for this clock. So I'm going to rethink the power source and probably go for some sort of electrical rewind system, but more on that later. So I'm just going to talk a little more about the design I've come up with, and I think the easiest way to show this is by taking it to pieces. And as you'll see, it's got a bit of a modular nature. So if I take off the dials, which are just blue tacked on, then I can remove the actual wheel trainwork. leaving the escapement and the pendulum in place. I think this could be very useful for working on the remontoir and the escapement. I should also point out that I'm really keen to have the remontoir and the escapement set in glass plates so that we can see what's going on, and we should be able to see right through to the pendulum support, and we might even be able to see the action of the pendulum spring while the clock is functioning. So this also comes off, leaving just the pendulum, and I've done a very rough suspension block with cheeks. So that's the sum total of my progress so far. It's been a bit slow, and I've gone backwards quite a few times, hit quite a few problems. I think one of the main problems was actually getting the decorative great wheels to sit in front of the clock plate. This was quite tricky because they're driven by wheels behind the clock plate, so their pinions had to stick through. This has also resulted in the clock getting really quite deep. So I'm not yet sure how the whole thing is going to look when I've mounted it in a wooden case, but hopefully next time I report to you, I will have thought about the case a bit and how to make it look balanced. And I hope I will have come up with the electrical rewind system, and I might finally have finished off a working model of the remontoir. Thanks for watching, and we'll see you next time.